Hello everyone. So today let's solve the problem integer break, right? So let's see what the question states here. Line number this one, problem number 343 basically. Given an integer n, we have been given an integer n. We have to break it to the break it into the sum of k positive integers. See, we have to break this one to the sum of k positive integers. So positive integers where k is greater than or equivalent to 2, at least 2, right? So and maximize the product of those integers and maximize the product of those integers. See, in the explanation, what we need to return, we need to return the maximum product that we can get that we can get. So here first we will break this one. Suppose let's consider 2 here. This one n equals to 2 they have given, right? So we have to break at least into two parts. K greater than or equal to 2 they have given, right, in the question. So we have to break this one at least into sum of positive integers here. This one we can just go with a 1 plus 1 actually. Yeah, 1 plus 1 lead, this one will lead into the 2. So this one we can just go it this one multiply this one into 1 basically. So see, we need to return the maximum product that we can get from that. So 1 plus 1, first we broke this one into 2 actually, right? 1 plus 1, then we are multiplying the same because we have to return the maximum product that we can get. 1 into 1, that is equivalent to the 1, that we need to return this one as the output. Next, we are considering n equals to 10. So this one, we can just break this one 10 into 3 plus 3 plus 4, right? So 3 plus 3, this will give us to the, this will give us 6. 6 plus 4 will give us 10. So then we can just multiply the same. Actually, 3 into 3, 3 into 3 into 4. 3 into 3 is nothing but 9. 9 into 4 is nothing but 36, right? So yeah, we can break this one. This is possible. Basically, the solution is possible. Accordingly with the question that they have given. So now they have given us wonderful examples just for the sake of understanding. Yeah, 10 can be broken into 3 plus 3 into 3 plus 3 plus 4, which is 3 into 3 into 4. So this will give us the 36. So this is fine. Now let's do one thing. As we are completely familiar with the question and the this one input output part, let's discuss the approach followed by the complexities. Yeah. Now, first, I'll just tell you one thing. We will be making use of the DP to solve this particular problem. So we will be going with a 1D DP to solve this particular problem. Just remember this one, man. Yeah, let's consider the same example, or let's go with a, second example for the just for the this one. What do we call? Just for a change. Usually we go with a example two, right? So let's go with the second example this time. So now let's go with when n equals basically 10, right? So we have to consider splitting 10 into the parts I, right? And then 10 minus I for all the I from 1 to 9, 1 to 9, right? So that's what we will do. We'll be doing the first step. We'll consider splitting 10 into the parts I and 10 minus I and 10 minus I for all I from for all I can just write here for all I from this one. Sorry, not belongs to basically for all I from I this one 1 to 9. For each split, take the maximum of these two things. For each split, take the maximum of I into this one. What do we call? Go with 10 minus I. Also go with I into this one dp of 10 minus I. So within the square bracket, I'll just give here into dp of 10 minus I. So this is nothing but the product without further breaking, right? 10 minus I, whatever we have considered this one. So this one I into dp of 10 minus I, this is nothing but the product using the optimal breaking of 10 minus I. So if you understand the first one, this is something easy, right? So this is fine, man. Now within the third step, what we will be doing, we'll be making use of the dp array. Nothing but we'll be let's consider as we have went with the I, we'll be going with the dp of j. We'll be making use of the dp array dp of j just to store the maximum product, right? So just to store the maximum product, I'll just write here maximum p. This is nothing but the maximum product for the integer j, for the integer j. This is fine. The final step here would be so we will finally will be going with a dp of 10 here, right? So n equals 10 we have been given. So dp of 10 will give the maximum product 36 basically. Here this will give the maximum 36 because 36 we will be splitting this one into 3 plus 3 plus 4, right? So 3 plus 3 plus 4 nothing but then we have to return the multiplication of these three numbers, right? Whatever the numbers that we have got, 3 into 3 into 4. So 36. So this is the approach that we will be going with to solve the particular problem. So before writing the code, let's discuss the complexities as well, man. The key insight here would be we have to break the n into numbers closer to 3 usually, right? Uh, Closer to this one 3 usually maximizes the product here for the example that we have considered, the second example. So what would be the time complexity? The time complexity would lead to big of n square, man. Right. So how it is n square? So we'll be going with the two nested loops, outer and the inner loop, right? So that you'll see within the code when we write the code. So one is from I equals 2 to n. Another one is j equals 1 to I minus 1. If you know what I'm saying, right? So the space complexity would be big of n, uh, because we'll be making use of the DP array of size n plus 1. So the space complexity would lead to big of n. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and big of n respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. First, let's initialize the DP array. So this one I'll just go with int recently in the this one. What do we call? Just now I said that we'll be going with a DP array of size n plus. Right. So let me initialize this one to new int of size n plus 1. This is fine. The next part would be the base case, only one way to break one. So there is only one way to break one. Though it is not, this will not be used in the final answer. Let's do this one still. So let me assign the DP of 1 to initially 1. So this is the base case. Now let's build the DP array from 2 to n. So we'll be going with the two for loops as I've said, right? Nested loop. So this one, first let's build the DP from 2 to n. So this one will be I equals to I less than n, I less plus. So this one has to be I less than or equal to n. Yeah. Now, let's do one thing. Let's go with Maxwell equals 0. Right? Maxwell equals 0. Yeah, let me give capital B here. This is fine. Yeah, now let's try splitting I into j and I to j. So this one will be for int j equals 1. This one will be j less than I, and this one will be j plus plus. Yeah. So within this for loop, what I'll do, let's go with a max of splitting once. Let's go with a max of splitting once or using already computed or the calculated dp of I minus j. So I can just write it in this way. Maxwell equals math dot um, math dot max of this one. What do we call? Maxwell, comma math dot max of this one. What do we call? J into hmm, I minus j. This would be j into I minus j. And it's j into what do we call? dp of I minus. This is fine. Yeah. Finally, so let me come out of this one entirely. We have to store the maximum product for I. So dp of I, we have to assign this one to the Maxwell. So after this, we have to go with the result, meaning maximum product for n. So this we have to return dp of n, right? In simple terms. So I'll just go with dp of n one. Yeah. So let me format the code once and let me hit the, for this one, let me hit the submit button directly. I think this is right. So I'm just going with the submit button directly. Yeah. Yeah, this works for all the test cases, right? So this is fine. Whatever the solution we have written, I hope it is completely clear. Uh, this one, along with the solution, the approach and the complexities are completely clear as well, I believe. Yeah, for now, this is it. Thanks for watching, guys.